So number 8 is a little bit trickier. The reason why it's trickier, it's because it's saying that line RS, let me go ahead and draw it. RS, this one, is the perpendicular bisector of JL. Right? So first let me explain to you what this is. Perpendicular bisector. So a perpendicular bisector, it's a line. First let me explain to you what perpendicular is. Perpendicular is like this. Right? These are perpendicular lines, right? And it could be at an angle too. What perpendicular means is that they form exactly the corner of a page, right? Or the corner of a book, right? 90 degrees. That's what all these are perpendicular. Bisector, right? Let me explain to you what bisector is. Bisector is that it chops it right in half, right? That's what bisector means. So let's say if I have this line that measures 8 units, right? Let's say it measures 8 units. I can't write well, but let's say this line measures 8 units from here to here, and then I chop it right here, right in the middle, right here like that, right in half. So now it's 4 and 4, right? This line, it's a bisector, right? And let's say I do another one. Let me undo this. Let's say I have another one that is diagonal. This could happen. Let's say you have it like that, and then you chop it exactly like that. And then now this is 3, and this is 3. That's a bisector, right? Because it chopped it right in half. If the line was 6 originally, that's a bisector. It cuts it in 3 and 3. But this does not form 90 degrees. You see, it's wider, right? So therefore, it's not a perpendicular bisector. So a perpendicular bisector means that it chops it right in half, and it forms two things, right? It chops it right in half. Let's say this is 5, 5, and 5. This measurement from here to here is 5, and from here to here is 5. That each side is 5, and it also forms this 90 degrees, right? So that's what I mean. This one's a bit tricky, right? So let's go ahead and look at this image, right? So it says RS, this line right here, RS is the perpendicular bisector of JL. Okay, so this line cuts JL in half, exactly in half. So let's say each one measures 4 and 4, right? It chops it right in half, and it's also perpendicular, right? Because it tells us right there. It tells us RS, which is this one, RS, is the perpendicular bisector of JL, which is this one. So we know that RS is the perpendicular bisector, right? So now the question is, can you conclude that K is the midpoint of RS? Meaning, if 4 and 4 are the same size, can we say that this side and this side are the same size? Can we say that, oh, that's 2, 2, 3, 3, 4, 5, 5, right? Or any size. Can we conclude that they're equivalent sides, that they measure the same? This side measures the same as this side. Can we conclude that? Well, no, you can't. That's not necessarily true, right? Because you can have a scenario like this, Jimmy. Let's say this is JL. JL is the same thing. It cuts it in 4 and 4, right? This side is 4 and this side is 4, and this is 90 degrees. So JL, it's a perfect line that's cut in half by RS. But look at this. This looks like a 2, and this looks like say a 5, right? The distance, right? The top looks actually much longer than the bottom, right? So no, you cannot conclude that, right? We can have scenarios where the top is bigger than the bottom, right? But we cannot conclude that K is the midpoint, okay? So let me go ahead and show you the original one. If we look at this image, it kind of looks like it is, but because it's geometry, we're trying to get your thinking knowledge to work. Can you just say, oh yeah, they're the same thing? No, you can't, because what about the top can be smaller than the bottom, and it actually looks like that to me. But all right, so we cannot conclude that K is the midpoint of RS. All right, so let me know if this is working, Jimmy. If not, I can elaborate more, but hopefully it's making sense. All right.